Welcome friends. Today I am taking linear programming problems to solve with the help of SIMPLEX method. This given problem, you can go through it. First of all, we are to study its nature. The nature is z maximum, where z is the objective function. Z is to maximize and all constraints are less than or equal to type. All the three given constraints are less than or equal to type. So this problem is pure maximization problem. Remember, if Z is maximized, objective function is to maximize, and all the equations, constraints are less than or equal to type, then it is pure maximization problem. These 5, 8, these x1, x2, x3 are the variables having linear relations, direct relations. And these 5, 10 and 8 are the coefficients of the variables in the objective function. Z is the objective function. And these 3, 5, 2 or 4, 5, 4, these are the coefficients of the variables x1, x2, x3 in three equations, first, second and third. So remember how to start. In pure maximization problem, when all the constraints are less than or equal to type and that is to maximize, then we are to use only slack variable. You have to use only slack variables. Different types of variables we will be using: basic variable, slack variable, surplus variable, artificial variable. But where is to be used? Which variable is to be used where? That is very important. When the equations are less than or equal to type, I am repeating, then we use only slack variables. And these slack variables are, say, S1, S2, S3. 3 equations, 3 variables. 2 equations, 2 variables. 4 equations, 4 variables. Slack variables are used. How these variables are used? These variables S1, S2, S3 are added into the objective function with 0 coefficient. 0s1, 0s2, 0s3. Number 1. There are 2 parts of only. Objective function, equations. So in objective function, slack variables are used with 0 coefficient. 0s1, 0s2, 0s3. And in equations, in inequalities, these variables are used with 1 coefficient in such a way that they form unitary matrix. 1 coefficient, say S1, here S1 only, here S2 only, here S3 only, with 1 coefficient, but in such a way that it forms unitary matrix. How? Now, let me use these variables. So maximum, Z maximum is equal to 5x1 plus 10x2 plus 8x3. Then all the slack variables 0s1, 0s2 plus 0s3. Subject to first equation 3x1 plus 5x2 plus 2x3. In first equation S1 is used with 1 coefficient, means only S1. S1 means 1 is already there. 1 coefficient means S1 is having coefficient 1, but you are not write down 1. S1 is having coefficient 1, but you are not to write down 1 because it is already there. 1 is already there. Plus S2 is not to be added in first equation. So it means 0 S2, 0 S3, and your inequality will become equal to 60. Similarly, in second equation, 4x1 plus 4x2 plus 4x3 plus here S1 will not come, so 0 S1, here S2 will come with one coefficient. With one coefficient plus 0 S3, and this will be equal to 72. Now third equation, 2x1 plus 4x2 plus 5x3 plus here no S1, no S2 means 0. Anything multiplied with 0, this is for the sake of symmetry. Then plus S3, and this is 100. And for all x1, x2, x3, s1, s2, s3 are greater than or equal to 0. This indicates that all variables are non-negative, because negative answer, negative number of anything has no meaning. So it is like this. So this is your equation has been converted into the standard format of the simplex method. Now we will put this format into our first simplex method. How to formulate the table? How to formulate the table? This is first is basic variable, and second will be solution variable. Basic variable we will call it as BB, basic variable, and second solution variable SV, basic variable. So what are basic variables? Slack variables are basic variable because slack variables are positive variables and they are added with a 0 coefficient in the vector function, 1 coefficient in the constraints. So basic variable, here we write on Cj. What is Cj? Coefficient, C for coefficient. Coefficient of objective function, Cj. Cj, coefficient of objective function. Now, here is the body of the matrix. Variables x1, x2, x3, s1, s2, s3. Like this. Basic variables are s1, s2, s3, and the coefficient, C for coefficient. Coefficient of x1, x2, x3, s1, s2. We have to write down over here in of the vector function, J for vector function. 5, 10, 8. Here 5, 10, 8. 5, 10, 8. 0, 0, 0. S2. X1, X2. So 5, 10, 8. Here 0, 0, 0. And solution variable, decision variable are this 60, 72, 100. Constant variable you can say. These are constant. 60, these are known as solution variable, decision variable. So this is 60, 72 and 100. Now these variables, the coefficients of these variables are put from this body of the matrix. Body of the matrix is 3, 5, 2, 1, 0, 0. 4, 4, 4, 0, 1, 0. 2, 4, 5, 0, 0, 1. The coefficient of slack variables are added in such a way that it forms a unitary matrix. Unitary matrix, the element lying at the diagonal is 1, 1, 1. This is known as unitary matrix. Now, you have put this body, this standard format into the first simplex table. Let me call it ST1. Simplex table 1. Or you can say the initial simplex table also, no problem. Then, second is to find out ZJ. ZJ. Z is the objective function. Here we are using the abbreviation ZJ. How to calculate ZJ? This into this plus this into this plus this into this. This into this means coefficient of Cj and coefficient of solution variable 0. Now 0 into 3 plus 0 into 4 plus 0 into 5, 0, 0, 0. Because you have to multiply it with 0 and add. Say this column 0 into 5 plus 0 into 4. When you are multiplying with 0, then everything will be 0. 0. Now Cj minus Zj. Cj, these are Cj, these are Zj. Now you have to calculate Cj minus Zj. 5 minus 0, 5. 10 minus 0, 10. 8 minus 0, 8. 0 minus 0, 0, 0, 0. This is a very important calculation, Cj minus Zj. Cj minus Zj. Now you have to study your Cj minus Zj. The maximum value of Cj minus Zj will decide the entering variable. Let me repeat. The maximum value of Cj minus Zj will decide the entering variable. The maximum value is 10. So this 10 is entering variable. Entering variable means what? This variable x2 will enter into the body of matrix. Entering variable. This is the first step. Entering variable. Symbolically we will be writing EV, entering variable. Now you have to calculate minimum ratio. Minimum ratio. How to find out the ratio? Ratio, you have to divide the solution variable by the corresponding coefficient of entering variable. Technique cannot be changed, will continue forever. It is divide solution variable with the coefficient of entering variable, this column. 72 will be divided by 4, 100 will be divided by 4. You will get the minimum ratio, 60 divided by 15, 12. 72 divided by 4, 18. 100 divided by 4, 25. Now as the column suggests minimum ratio, so minimum ratio is minimum number positive. Minimum number positive. No negative. Negative ratio is not to be taken into consideration. No negative. And if the division is by 0, then anything divisible by 0 has no meaning. So it is expressed by the word infinity. So these two things, negative ratio and an infinity ratio, will not be taken into consideration in any case. But here the minimum is this. This means this is leaving variable. This is leaving variable. LV. Leaving variable LV. This means what? This leaving variable means S1 will leave the body of the matrix. S1 will leave, and in place of S1, X2 will enter. So S1 will go in the next table, and in place of S1, X2 will enter. And the element which lies at the intersection of entering variable and you can say column and row is known as key element. Element lying at the intersection. This is the element 5. This is known as key element. Key element. This key element is very important. Now we have to take this table into the second table. Then we have to divide key element with the same number because we want key element as 1. We want key element as 1. Then we will have to divide this 5 by 5. Not only 5 by 5. We have to divide the whole row with 5. Whole row with 5. And other elements lying in that column will be 0. 4, instead of 4 we want 0. Instead of 4 we want 0. Then we have to decide. If we get 1 over here, then we have to multiply with 4 and subtract from here. Similarly, subtract from here. So in the second table will be, let's now formulate the second table. Now second table is, what are the techniques to be followed? Divide first row by 5. BV, basic variable. SV, solution variable. Now S1 will go. Here in place of S1, X2 is to be added. X2, S2, S3, X2. So you have to divide by 5. Solution variable 12. X1, X2, X3, S1, S2, S3. Now 3 by 5, 1, 2 by 5, 1 by 5, 0, 0. Now we want 0 over here. It means we have to write down this row and subtract this row after multiplying with 4. So this you have to have fair calculations, or you have to show the calculation how you have arrived the result. So this is your S2 row, 72, 4, 4, 4, 0, 1, 0. This is your second row, S2 row. Now multiply this row, new row, with 4. Because here if 4 comes, then you will get 0 over here. Right? So now multiply this row, new row, with this row with 4. X2 row. You may not write like this. 12 into 4, 48. 12 by 4. 12 by 5, 4. 8 by 5. 4 by 5. 0, 0. No. Subtract. Because we want 0 over here. So 72 minus 48, 24, 4 minus 12 by 4 minus 12 by 5. So this is equal to 20 minus 12 by 5, 8 by 5. This is 0. 4 minus 8 by 5, 4 minus say 8 by 5, then it is 12 by 5. 0 minus 4 by 5 minus 4 by 5. This is 1, this is 0. Now write down like this. S2 is, this is now S2 row, 24. 8 by 5, 0. 8 by 5, 0. 12 by 5, minus 4 by 5, 1, 0. This is the calculations of this row. Now S3 here, again we want 0. Now we have to write down this row. This is 100, 2, 4, 5, 0, 0, 1. Now this is the same here. 48, 12 by 5, 4, 8 by 5, 4 by 5, 0, 0. Same. That is multiplying this by 4. This by 4. So subtract it. This is 52 minus 2 by 5, 2 minus 12 by 5, minus 2 by 5, 0. 5 minus 8 by 5, 17 by 5, minus 4 by 5, 0, 1. Now write down over here, S3. S3, it is 52 minus 2 by 5, minus 2 by 5, 0, 17 by 5, minus 4 by 5, 0, 1. No. Let's complete. Now Cj. Cj is x1, x2, x3, 5, 10, 8, 0, 0, 0. Here x2 coefficient is 10 and S2 is 0, S3 is 0. Now we have formulated the simplex table second. This is your simplex table second. This is your simplex table second. st second. Now again, same procedure. First of all, we are to calculate Cj. Cj means this into this plus this into this plus this into this. Similarly, this into this plus this into this plus this into this. Same way, this into this plus this into this plus this into this. Multiply by Cj coefficient Cj with the coefficient of Cj and variables. Like this. Now, so 120 here, 10 into 30 divided by 5, 6, 10, here it is 24, here it is 2, here it is 0, here it is 0, Cj. Same technique. This into this plus this into this plus this into, like this. This into this plus 0 into this plus 0. So easy to calculate. Now Cj minus Zj. Cj minus Zj. This is Cj and this is Zj. Cj minus Zj, 5 minus 6, minus 1, 10 minus 10, 0, 8 minus 4, 4. Now minus 2, 0 minus 0 minus 2, minus 2, 0, 0. Now Cj minus Zj, you have to study this row. The maximum positive value, maximum negative, no negative. Maximum positive value will be considered as entering variable. So maximum positive value is 4. And this is your entering variable. Short frames entering variable. Now you have to calculate. Next is minimum ratio. Minimum ratio. This ratio is calculated by dividing the solution variable with the coefficients of entering variables, corresponding coefficients of entering variables. 12 divided by 2 by 5. 12 divided by 2 by 5, 30. No. 12 divided by 2 by 5. Okay. 24 divided by 12 by 5. 24 divided by 12, 5. 10. Then 52 divided by 5 by 17. 5 by 17. This is 17. Okay. This is 0. 17. 1. 15 point something. It is 15.3. Now the minimum ratio. The minimum positive, no negative, no infinity. So this is minimum, and this minimum is indicating leaving variable. Indicating leaving variable LP. It means what? S2 will leave the table and X3 will enter. And the element lying at the intersection of these two row and column, element lying at the intersection of this leaving variable and entering variable is this. This is known as key element. This is known as key element. Now you want to make key element as 1 here and 0 over here, 0 over here. This is all mathematical calculations, simple basic mathematics. If you want to make 1 over here, then you have to divide by this, divided by 12 by 5. Or you can multiply by 5 by 12, you will get 1. Then you have to multiply or divide the whole row. So let's form the next table now. Then basic variable, solution variable. Here x2, you can write on 10. We know what is x2's coefficient. Now x3 will come. X3 will come in place of S2 and its coefficient will be 8. This is your Cj. x1, x2, x3, s1, s2, s3. Now, coefficient are 5, 10, 8, 0, 0, 0. Now, calculations. And S3 will remain as it is 0. Now, this is the key element row or column where lying at the intersection, you have to make it 1. Then multiply this by 5 by 12. Because you have to make it 1, multiply the whole, every element, each and every element with 5 by 12. So 5 by 12 you have to multiply. So this is 24 into 5 by 12, 10. 24 into 5 by 12, 8 by 5 into 5 by 12, 8 by 5 into 5 by 12, 4 by 3, 8 by 5 into 5 by 12. Now 0 is 0, this is 1, 5 by 8 into 5 by 12, minus 4 by 5 into 5 by 12, minus 1 by 3, minus 1 by 3. This is 5 by 12 and this is 0. Now, this is your new row. Now you want this point, this 2 by 5 as 0. It means you have to multiply this row by 2 by 5 and subtract from here. You have to multiply this new row with 2 by 5. Why with 2 by 5? Because here it is 2 by 5. Then subtract that row from this old row, you will get the new row. You will get the new row. So let's do that. 12, 3 by 5, 1, 2 by 5, 1 by 5, 0, 0. Now multiply this by 2 by 5. 2 by 5, the whole row 2 by 5. 10 into 2 by 5. 10 into 2 by 5. 4. 4 by 3 into 2 by 5. 8 by 15. 0. 0. Then 1 into 2 by 5. 2 by 5. Minus 1 by 3 minus 1 by 3 into 2 by 5. Minus 2 by 15. 2 by 5. Then 5 by 12 into 2 by 5. 1 by 6. 0. What is being done? We want 0 over here. So writing this row as old row, multiplying this new row with 2 by 5 and writing down over here and subtract. Now 8, 3 by 5 minus 8 by 15, 1 by 15. 3 by 5 minus 8 by 15, 1 by 15, 1, 0, 1 by 5. This is minus, so it will become positive. 2 by 15, 15, 3 plus 2, 5 by 15. Then 0 minus 1 by 6, and this is 0. So write down this new row over here. 8, 1 by 15, 1, 0, 5 by 15. 5 by 15 you can write down 1 by 3. 5 by 15, 1 by 3. Minus 1 by 6, and this is 0. Now, here it is 17 by 5. We want to make it 0. It means this is our new row. This is our new row. Then write down this row, old row, and subtract the new row by after multiplying it by 17 by 5. Now, this is your new row, old row. 52 minus 2 by 5, 0, 17 by 5, minus 4 by 5, 0, 1. Now, this is your new row. Multiply this with the 17 by 5. 10 into 17 by 5. 10 into 17 by 5. 34. This is 0. Oh, here is not 0. This is 4 by 3 into 17 by 5. Into 17 by 5. This is 51 divided by 15. This is 0. This is 1 into 17 by 5 minus 1 by 3 into 17 by 5. It is minus 17 by 15. This is 5 by 12. 5 by 12 into 17 by 5. 17 by 12. And this is 0. Now subtract. 52 minus 34, 18. Minus 2 by 5, this is to be subtracted. Minus 2 by 5, minus 51 by 15. Minus 6, minus 57 by 15. This is 0, this is 0. Minus 4 by 5 plus 17 by 15. 4 by 5 plus 17 by 15, it is 5 by 15. 5 by 15 or 1 by 3. And this is 0 minus 17 by 12. And this is 1. This is your new row. So here it is 18. Here it is minus 57 point by 15. 0, 0, 1 by 3, minus 17 by 12 and 1. A new table, this is table, simplex table 3 we have found. Again, we have to go for ZJ and then CJ minus ZJ. ZJ we know this into this plus this into this. This is 0. So 80 plus 80, 160. This is, say, you have to make the calculations to avoid any mistake. 8 into 10 into 115. This is 10 into 115, 10 by 15 plus 32 by 3. This is 0. So this is 15. 10 plus 96. 106 by 15. 106 by 15. And this is 10. This is 8. Very simple. Then 10 by 3 minus 8 by 3 plus 0. So this is 2 by 3. 2 by 3. Now this is 10 into 1 by 6 minus 10 by 6 plus 8 into 5 by 12, 40 by 12. So this is 0. This is 12 minus 20 plus 40 is equal to 20 by 12. You can write down short way and 5 by 3. So 5 by 3. Here 0, 0, 0. So only 0. Again we have calculated ZJ. Now CJ minus ZJ. This is CJ. This is CJ. This is CJ. 5 minus. Now 5 minus 106 by 15. 90 minus 106 by 15. So this is equal to minus 16 by 15. So minus 16 by 15. 10 minus 10, 0. 8 minus 8, 0. 0 minus 2 by 3, minus 2 by 3. 0 minus 5 by 3, minus 5 by 3. 0 minus 0, 0. Now, again we have to check for any positive maximum number for Cj minus Zj. Here we find that the value of Cj minus Zj are either 0 or negative. There is no positive value. It means we have reached at the optimum solution. Why? This we have to write down. Since for all Cj minus Zj, these last row, these all Cj minus Zj are less than or equal to 0, means either they are 0 or less than 0 means negative. So there is no positive value. So it means we got optimum solution. We got optimum solution. Then how to write down the solution from the last table? You have to write down the solution from the last table. Here you have got x2, x3. These are your decision variable. S3 is basic variable, 0 coefficient. So x1 is not here. It means x1 should be 0, x2 is 8 and x3 is 10. So only two variables should be selected. x2 8, x3 10 and x1, because x1 is not there, so it should be 0. And the maximum value Z maximum is to be taken from this Zj. From this Zj, that is 160. 160. So this is the answer. Now you can check these number with the help of your objective function as well as your constraints, and they will tally hold good. So this is actually simplex method. Here you may get the value of even one variable, two variables, sometimes all the three variables, depending upon when you reach at the stage or at the point when all the Cj and Zj are less than or equal to 0. I think you have followed. Thank you very much. Please like, subscribe and share my video. Thank you very much.